Hello everyone. So today we are going to learn collection interface classes. In earlier classes we have learned about list interface and ArrayList class. So in this tutorial we will be learning about LinkedList class. So we have learned earlier that collection is an interface and it constitutes three of the interfaces like list, set and queue. Within list we have subclasses like ArrayList, LinkedList, vector and stack. So we have covered ArrayList class. So in today's session we'll go through LinkedList concept. So actually linked list is a class which comes under list interface. So the underlying data structure of this class is double linked list, and insertion order is preserved here so that whatever elements we have inserted, so the order will be preserved. We can get to know that at what index those elements have been added. In linked list class we have benefits of that duplicates are allowed here. We can insert duplicates elements in linked list class. Also here heterogeneous objects are allowed. Heterogeneous object means elements from different collection objects, so that will be called heterogeneous objects. Null insertion is possible here. We can insert null elements. Also, linked list implements serializable and clonable interface, but not random access interfaces, because random access interface is implemented by ArrayList class. So you might be having question that what is actually random access interface. So random access interface is present in java.util package. So it is an interface which is present in this package, java.util.package, and it does not contain any method, and it is a marker interface, so it won't be having any method. Also we might be thinking that what is serializable and clonable thing. So usually we can use collections to hold and transfer objects from one place to another place. So to provide support of this requirement, every collection class like ArrayList, LinkedList, vector, stack, tree set, so these implement serializable and clonable interface. So going forward we'll learn about clonable and serializable in detail. So as of now we just learned that linked list implements serializable and clonable interfaces but not random access interface. Now the next point is that linked list is the best choice if our frequent operation is insertion or deletion in the middle. Okay, and linked list is the worst choice if our frequent operation is retrieval operation. So why so? Because it actually has whatever element we want to insert. So in the middle we can get to know that what index is there for a previous element and what index is there for after elements. So previous and after, in between them we can insert a new element. So that is why linked list is the best choice. If our retrieval operation is there, then if we want to go to a particular element, if we want to retrieve that, so we need to go through each and every element of linked list till that element. So we have to actually iterate from the first of element till that element. If we want to retrieve some elements which is in middle of 7th index, and the total collection has got 10 elements, so for getting that 7th element we need to go through all 6 elements, and then only we can get to that 7th element. So this is why it's there. Usually we can use linked list to implement stacks and queues. Now we'll see that what all constructors we used in linked list. So the first one is linked list L1 equal to new linked list. So this will create an empty linked list objects. It won't be having any element. It just creates an empty linked list object. The second constructor here is linked list L2 equal to new linked list collection C. So it will create an equivalent linked list object for the given collection. Whatever collection object we have given, so equivalent to that object, it will create an equivalent linked list objects. And it does not reserve any memory by default, unlike ArrayList. So it won't contain any extra memory. So it won't be having any predefined memory, unlike ArrayList. We have learned that in ArrayList by default it contains some capacity. So in ArrayList, if we don't provide anything, any capacity, then it will take 10 as the capacity for initial thing. Likewise, it is not possible in linked list case. So we'll go through an example. So this is the example. Before that, we'll go through what all methods we used in linked list. So the first one is void add first. So this is used for adding an element in the linked list. The next one is void add last. So it will add the element at the last position. Next one is object get first. So we can retrieve one element from that linked list. So the return type will be object, as we are getting an element here. So the first element will be retrieved from this method. The next one is object get last. Similarly, it will return an object at the last position. The next one is object remove first. So that will remove the first element of our linked list. And the next one is object remove last. So it will be used to remove an element at the last position. So likewise, we know that stack is having last in first out methodology, and in queue we have first in first out methodology. And now we'll see an example. So we have written import java.util.star. Then the next statement is public class linked list demo. Here we have got a method public static void main string args. Now the first one is linked list L equal to new linked list. So we have created a linked list with name L. In the next statement, we can see that we have written L.add Durga. So Durga will be added in our linked list. The next one is L.add 30. So 30 will be added. We have just learned that in linked list we can store heterogeneous objects. So that is why we are able to store 30 here. The next one is L.add null. So null insertion is also possible in linked list. So null we can put here. The next one is L.add Durga. We have learned that we can insert duplicate values in our linked list. So that is why we are able to put Durga here. Then L.set 0 software. So this will replace the element at 0th place. So at 0th place, software will be written. If we see from beginning, at 0th place we have written Durga. So this Durga will be replaced by software. Now we have written L.add 0 workey. So this workey will now be inserted at 0th place. Then we'll write L.add first CCC. So at the first place CCCC will be inserted. Now when we'll write system.out.println, then we from println of L, then we can see output as CCC, workey, software, 30 and null. CCC we have inserted element at the first position, that is why CCC is there. Before that also we have written workey at 0th place, so at 0th place workey were there, and after that CCCC were inserted. In the same way all the outputs are there. Now we'll quickly go through some points about differences between ArrayList and linked list. So in ArrayList, it is the best choice if our frequent operation is retrieval, and in linked list, it is best choice if our frequent operation is insertion or deletion. And in array list, it is a worst choice if frequent operation is insertion or deletion, whereas in linked list it is worst choice if our frequent operation is retrieval operation. Underlying data structure for array list is resizable or groupable array, whereas for linked list the data structure is double linked list. Also, ArrayList implements random access interface, whereas LinkedList does not implement random access interface. So this was all for the day. Let me know if you are having any query regarding this. Thank you so much. Signing off, Chitra. Bye bye.